important. Sorry, this is important. Okay, so our topic of today is exponential and logarithmic equations. And this is like an example that I wanted you to see. Your test coming up is on exponents and logarithms, and I have two problems. Don't they look almost alike? There is a big difference. Sometimes when you see problems like this, they can be solved really easily using exponents. And other times, like you saw on your take-home quiz, right? Saturday, at a certain point, you were like, what? I'm done. There's nothing more I can do. I probably just have to guess at it. So here we go. Here we go. We're going to separate it off. If you're doing the problem on the left, Dan, man. Okay. By the way, this is what your paper should look like. You see how everything's like in between the spaces and where the lines are drawn? What do you mean? What's wrong with that? Yeah. It's going to get really annoying. Whoops. Oh my God, look. Look, hold on one second. Let's find somebody. Star? Yeah. You try and rewrite them using the same base, right, Star? Okay, perfect. And 2 to the third is the same thing as saying 8. Naomi, you're up. Sure. Yeah, look, there are two quantities set equal to each other, and these two parts match. So the only way that they could be equal is what? Is if these two top parts match. And hold on. I know you guys don't have all these tools or a pencil case like I would have, but if you did, you know, like I would highlight this. What? Whatever. Don't judge me. I mean, I'm not going to lie. I think that's pretty cool. Showing you. I do have a pencil case. Okay. No, I bought that for this year. Thought it was cool. Okay. So here we go. So what's next? Yeah. Let's do it in one final different color. Subtract 1. Subtract 1. Crossing that off. X equals 2. That's your final answer. Ooh. Ooh. Hold on one second. So that everybody gets a chance. Oh my. Let's go again. Both problems look alike. Both problems start off the same way. Let's do it again. Brandy girl, tell me what I did. Yep. And in fact, I'm going to do it in a different color. So we're going to get 2 to the x plus 1 equals, Brandy girl, what's 17 minus 5? No calculator. Good. And it's at this point in your calendar quiz, this is the same problem, right? You were stuck. What do? Somebody that got the question, how did you solve it? Larry, did you solve it? Anybody in here managed to solve it? Julio? Oh, you used the logarithmic equation, like the stuff that we were learning? What did you do? Logarithms. So let's see. 2 to the, hold on one second. Action. So Julio showed his own original way of doing the problem. I'm going to show you another way of doing the problem. Does everybody have a graphing calculator? Come on, Teddy, time to go. Okay. So here we go. Here's another way to solve the same problem. Okay? Grab your calculator. We're going to solve it graphically. Everybody hit the y equals screen. In order to solve a problem graphically, take the left side of the equation, enter it into one of the one of the y equals blanks, take the right side of the equation, enter it into the other, and then guess what you're going to go looking for? Yeah, where they intersect. Teddy, in Algebra 1, no problem. You could probably find it in the table. But in this course, random answers. Not random. I should say irrational numbers become your answers. Okay. Sure. So take a look. Does everybody have this picture in your calculator? Sometimes you have to adjust your window. How do you go and find the point of intersection? Dan? Yep. Anytime you want to do something graphing in your calculator, the buttons associated with it are typically up over here. And this calc button is one of the more valuable buttons you will ever push. Go down to intersect, hit enter, and then hit enter 3 times. 3 times. 1, 2, 3. Same answer. Same answer. Approximately 2.58. That way is easier, right? Now, that'll only get you full credit if it says solve. But if it says solve algebraically, Julio's method that we showed up on the blackboard is perfect, and I'm going to show you another method that you can do that sometimes is also that people like to use a lot. Here we go. You ready? Now bear with me on this. Bear with me on this. Here's what we do. Here's what we do. So here we go. Here's the other way. And I know it looks a little weird, but I'm going to explain to you what's up. Okay? You log up both sides. You log up both sides. Why would you want to do that? How does it help you? Yep, you're allowed to do this because it's an equation, property of an equality. You can do whatever you want as long as you do it to both sides. So we've logged up both sides. Now, why would you want to do it? How does it help you? Why would you choose logarithms of all the tools in your box? Properties of logarithms, right? There's a particular property that's going to help us out. The problem that we're faced with is that the x is stuck in the exponential spot. So now that they're both logged up, what can you do? You can drop it down. Yeah, and that's the whole reason for doing this. This now, according to, that was really messy, and you know I can't have that. Right? This, because it's in the exponential spot, and because we're using logarithms, drops down in front. That's called the power rule. We get x plus 1 log 2. Oh, come on, computer. Log 12. Okay, let me scroll down for a minute. What do you think we do next? Jamal, what do you think, buddy? Okay, perfect. So the next step is dividing by log 2. Divide by log 2. And you can see that my method actually resembles Julio's, right? A little bit. We get x plus 1. Oh boy, that's really messy. Oh, come on, computer. And finally, what's the last step, Julio? Yeah, you subtract 1, just like you did, man. Subtract 1 from this side. Subtract 1 from this side. These cancel off. And let's get our final answer for what the problem is. And let's show how we would punch it into our calculator, right? X is going to be equal to, right? Log 12 divided by log 2 minus 1. And so x is approximately, let's punch it into our calculators, log 12, log 2, enter, minus 1. See, I did it in steps? 2.58. So here we go. Here's the property that we learned today. I chose to change a bit of the formula up. I hope you understand it. Instead of saying x's, because sometimes people get confused, I chose to use shapes. They represent quantities. So if you have one quantity equal to another quantity, then the log of both of those quantities is equal to each other. Maybe I should also do this to indicate that sometimes they might look a little different, but they're equal to the same amount. One will be red, the other will be green. But you get my point, right? Does anybody like using x's and y's better than shapes? You use A and B? Okay, that's fine. I'm trying something new. Hello, everybody. Hello, everybody. What's step 1? What do you think we're going to do? Perfect. Yeah, you just log up both sides. Step 1. Log up both sides. Log 2 to the x equals, come on, computer, equals log 5. Big Larry? What goes down next? Where are we moving it to? Yeah, we're dropping it down in front. So it's x log 2. Oh, I just have to go real slow, I guess. Yeah. Oh. You see how the computer's moving real slow? Does anybody study computers? Know anything about how to fix that problem? Nope. When you want to run lots of programs at once, how do you improve a computer to make it be able to do that? More what? Good. Yep. We need more RAM. Oh, you like the graph way? You're okay. Just don't become addicted to that. You know why? Okay, good. So we get x is approximately equal. Now, what did I ask you to round it to? Yeah, the question is which spot is that? The spot after the decimal is the what spot? 2.32. Let's play again. Skolnick, what do you think you do first? It's been the first step for the whole day. I'll give you a hint. The number's just in a different spot. Perfect. Yeah. Right. Whoa. Shoot. It is an excellent question, and that's our topic of discussion for tomorrow. Can you or can't you? First, let's just check to see if you can put negative numbers in. Julio, what were you going to say, buddy? You, -2. Ah, you've seen the shortcut already. Yeah. There's all different types of ways for attacking one problem. You've automatically figured out how to solve it real fast. Nope. Nope, nope. You don't have to use logs at all. You can. I'm going to show it. I chose an easy problem so I could show one particular point. Watch what happens if you try and do the logarithm of a negative number, like -2. What'd you get?
Oh, no. I got.
You got a random answer? Yours might be set to, you know what? Yours might be set to a plus bi mode, so it'll do imaginary numbers. But here's what we're going to do. So this is our topic of discussion for tomorrow, and think about it when you do your homework tonight. Why you possibly could not do it. In the meantime, how could you adjust the problem so if you can't? What's up? Perfect. We're dividing by -1. So let's write this down. Oh, come on. Can't take the log of a, oh, come on. Oh, this is frustrating. Of a negative number. Okay. So here we go. To compensate for that, we're dividing both sides by -1. That's perfectly allowed. So that you get 2 raised to the x plus 7 equals 2. After that, using the method that we learned today, how would you solve such a problem? Hilner? Not Julio's way. It's Julio's the man, we all know. He's created a very smart method. What was the method that I taught you today? Just as a backup. You put what? Ooh, you missed. You're moving too fast, right? Take a look at our notes, right? What do you have to do before you drop that thing down? Yeah, that's important. Very important. So we're going to log up both sides. You get the log of 2x plus 7 equals the log of 2. Just as you said, buddy, this drops down in front. X plus 7. We'll put it in parentheses. Log 2 equals log 2. That's fair. That's fair. You know what? I appreciate that you like the graph method. You know, I can already tell you I pretty much know what your exam is going to look like then, right? No, I'm not saying about the grade. What I'm trying to say is I love the method itself. If you encounter a problem that you don't know, I happen to know that you're probably going to draw a graph, and I can show you some more skills so you can earn some more points. But if this is something you're weak in, don't just let it go. Maybe it's plan B and the graphing is plan A, but you're still going to have to try.
I like this. I understand it, but I like the security, knowing that I have to try to graph.
That's cool. What's log 2 divided by log 2 going like before our time? Yeah, it's just 1. And then what do you do from here? Yeah, we're just subtracting 7 from each side. Yeah, and that's your final answer. Skolnick, I'm going to take your question in a minute. Here's your homework for tonight. It is 2 questions. That's it. That's all I got for you. Because